Welcome back, everyone. I'm Blue Dolphin with the Hoplite Security, and we're going to be jumping in to a overview of the Hack the Box Precious Machine in 60 seconds. So we start off phase one, as usual, with a little enumeration of our machine. We do a little web enumeration, learn about the subdomain. From here, we do some research and learn there's a web application that is running. This is a web page to PDF converter. We find a CVE for PDF kit in Ruby, and we exploit that to get a reverse shell with limited privileges on the box. From here, we locate user credentials for horizontal movement and have SSH access as an elevated user. For the root phase of the machine, we do some internal enumeration. We find a sudo run as permission on a .rb file, which calls a dependency.yaml file. We replace that dependency.yaml file with a malicious one, and that executes our code and gets us the flag. Let's get into it. Jumping right into things here, we'll start off with our nmap scan as usual, where we learn about two ports. So 22, our SSH port, and port 80. This is going to be our only attack surface here, as there's no other ports, nothing on UDP, nothing above the standard top 1000 ports. We do see that our web server is running Nginx, and it's version 1.18, which I think is fairly up to date. It talks about a redirect to precious.htb for a domain name. And with this being our attack surface, what we're going to do next is add the precious.htb domain to our Etsy host file, and we're going to run WhatWeb on this web application. So before we start learning what it does, we can learn a little bit about the technology stack behind it to be a foundation for our enumeration phase of the web application. So here I'm just running WhatWeb against precious.htb, and I have added this to our Etsy host file. Okay, so for some reason, running WhatWeb against the precious.hackbox domain didn't work, which is odd. When I originally did this box, it did work, but I used it against the IP address and we still got the results I was looking for. And this tells us everything about the application stack. So what we can see is that we have an HTTP server of Nginx, and then our web application server, which is right here, is Fusion Passenger, which is a Ruby on Rails framework. And the title or the purpose of this app is to convert web pages to PDFs. So just to recap, we have the Nginx for our web server. Fusion Passenger is our web application framework, and that is written in Rails, Ruby on Rails, sorry. And then the purpose of this application is to convert the web, like a web page, to a PDF. Before having even looked at it, we now have this information. So this is going to help with looking for vulnerabilities. We're going to keep them focused to Ruby, for example, if we are playing around with the web application. So let's go ahead and take a look at it. Here we have the convert web page to PDF web application, which is a Ruby application built on the Fusion Passenger web app framework, or web dev framework, if I understand. And it just simply wants to convert a web page to a PDF. So I'll just go ahead and enter Google. Let's just see what happens. It says you should provide a valid URL. So let's go HTTP, and we'll just add the google.com. Okay, let's just do google.com. And it just says you should provide a valid URL no matter what. Okay. Well, from here, originally, I recall not getting anywhere. So what I did was I went over to Google and okay, here we go. So it says cannot load remote URL. So this tells us that it probably can't reach the internet, this application, and it's just local, which means we have to probably serve something to it. So what happened from here is I started doing some research around online, just around the keywords that we found earlier, right? Convert web page to PDF, Ruby on Rails. And I did come across this website here to do with command injection regarding PDF kit. And it looked very accurate to what we were dealing with. A PDF kit package, and it's the Ruby PDF kit. And if you look up the Ruby PDF kit, you're going to see that its job is to convert various docs, especially web pages, to PDF. So I felt like this was kind of guesswork on my part. But anyways, moving on, there's a POC here that we can use, and it's basically what we see right here. So what I initially did is I literally just copied this example and passed it along. Sorry, I didn't copy that one. I copied this one here. So what's happening is the application is vulnerable when it tries to render a URL that contains a query string parameter with user input. So what we do, and what we're seeing here is how it's processed on the back end. When it says PDF kit new, you get this file and use a toPDF function. And that's what's going on. So we're literally just going to call just the URL, which has the input or the query string parameter and a sleep, an SQL sleep payload. If I understand it, we're just going to paste this in. And then what should happen is we should see this go to sleep, but I actually found this a little difficult to know what was going on. So when I entered this, it does hang up in all fairness and then eventually provides output. So I started trying to get it to ping my host, and I tried some, I don't remember what else I tried actually. But eventually I just started going for a reverse shell, and that took a while. It took me days to get the reverse shell. So I'm just going to copy the payload that I used over here, and I'll quickly walk everyone through it. So you can see this is kind of the initial payload, but it doesn't really go anywhere. So what I've done here instead is I've taken the same payload, but I've now separated it with the quotes, and I have added bash, and I call bash standard in dev TCP and our machine, and this is for the reverse shell. So let's go ahead and execute this. And you can see my listener on the left and our payload here. So we're going to pass this through. And there you go. We have our reverse shell. So again, we just used an escape character. And from here, we were able to, I believe our escape character was the %20, which is a URL encoded quote. Actually, I don't really know. I know I just copied the payload and I played around with it while adding the bash command inside to get that reverse shell. So anyways, we're in here as user, so we can go who am I? And we are user Ruby. All right, let's jump into the root phase. All right, so for this phase, I actually struggled a bit. I was looking around left, right, and center, never really figured it out until I realized that where I needed to start was simply just in the root directory where there was a hidden folder called .bundle. All right, so just looking in the home directory, you see we have user Henry and Ruby. Well, user Ruby in her directory has something interesting, the .bundle. Now, she doesn't have the flag.txt, which means we're going to have to move horizontally to user Henry. So starting here, what we can do is, again, this took me ages to figure out, but if we actually look at this, at the bundle directory, sorry, it's a file, this will actually show us, no, it is the directory. Sorry, it's been a while since I've done this. Well, see here we have a config file. Well, if we look at the config file, or to change directories to it, for some reason this machine is freezing up, but if you just cat the config file, it's going to show you credentials for user Henry, and then you connect back in with SSH. So I'm not too sure what's going on here, but I'm on standby just trying to connect in. And I don't know if I'll be able to show this part just because, again, the box keeps freezing. But yeah, really sorry I can't include this in the video. But we'll just go ahead and keep moving forwards with credentials from user Henry. So again, just to recap, you get onto the machine by using the payload and modifying a bit for the Ruby PDF kit converter. Use that, get the reverse shell, get on the system, look in user Ruby's folder, and you'll find a hidden file or a directory, which is a .bundle file. And in there, you'll find a config file. You'll cat that, and you'll get user Henry's username and password. All right, let's jump in as user Henry. All right, so I'm in here as user Henry. I've done some reboots, so hopefully everything's working now. Let's go ahead and jump right into this though. The way to get root on this machine is to run sudo l to check what sudo run as commands you have, and you can see that you're able to run user bin ruby opt update dependencies .ruby. So the first thing we want to do is obviously go and take a look at exactly that. So let's go cat opt update, and it knows exactly what we want. So looking through this, we can see that the design of this program is to compare installed dependencies with those specified in dependencies.yaml. So we can see right here, it's installing, or it's comparing stuff installed with those in dependencies.yaml. And as we look through here, we can see that it reads dependencies.yaml. So what we're going to do here is one of two things. One, I think there was a way to just craft a malicious dependencies.yaml file, but I couldn't get that working. I got it kind of working, but then I settled on setting a symbolic link to the flag via a pointer attached to right here, dependencies.yaml for when it calls it. And then what happens is we just run, Ruby opt update dependencies.rb, that calls dependencies.yaml, or YAML, and it executes our reverse shell. So let's go ahead and do that. In order to do this symbolic link properly, we're first going to need to conduct a little path hijacking, because you can see I tried to do a symbolic link on dependencies.yml to point to root.root.text, and here it said permission denied. So what we need to do now is create our own dependencies, but where would we put that? Well, if we take a look at our environment, we can see that our path here is just going to be user local. So let's go ahead and just jump in our home directory here. I think this will work. And we'll create a dependencies.yml file and execute that with symlink. All right, so what I've done here is I've just backed up to my home directory where I've done a symbolic link for root-root.text to dependencies.yaml. So now what we have to do is actually call dependencies, the update dependencies, which will then call dependencies.yaml, which is nothing more than pointing to read@root.text. So let's give this a shot. We'll go sudo user bin ruby opt update dependencies.rb, and perfect, there it is. You can see we have our flag right here. So what's actually happened is this program has errored out at this part because it's reading the string, but it doesn't mean anything because it's looking for dependencies.yaml. So it reads this and errors out and gives us the standard error. So that's our string. And other than that, that's a wrap. See everyone in the next video.